So suppose you are just sitting in math class watching the birds out the window when your math teacher calls on you and asks you if 3 is a rational number or an irrational number. Well, what is a rational number? A rational number is any number that can be written as a fraction or a decimal, and any number that can't be written as a fraction or decimal is considered irrational. So we have this lovely chart on the bottom. And as you can see, all the numbers in the red circle are rational, and all the numbers in the green circle are irrational. So rational numbers consist of any numbers that can be written as a fraction or decimal, like integers and whole numbers, and just these numbers over here that can just be written as a fraction or decimal that are neither integers or whole numbers. And then irrational numbers consist of square roots that can't be simplified to a whole number, or pi, and so on. Now, not all decimals are rational. There are terminating and non-terminating decimals. Now, if something terminates, that means it ends. So using that, we can conclude that terminating decimals, they end, and then non-terminating decimals, they never end. Now, suppose we have the decimal 0.45. That would be considered terminating because it ends. Now, if we have pi, then that would be non-terminating because that never ends. Now, you can divide non-terminating decimals into two categories: repeating and non-repeating. Repeating decimals have the same digits that repeat over and over again. And the non-repeating decimals have several digits that never end and don't repeat. So they're just in a random order. Now, when I say that, that doesn't mean that non-repeating decimals can just be in a random order and they don't follow a pattern. If you have the number 0.040040004, then you might be thinking that that number is repeating because 0 and 4 are repeating over and over again. Well, this number is actually non-repeating because it may be following a pattern, but repeating decimals don't follow patterns. They have the exact same digits repeat over and over again. So if I had the number 0.376376 and so on, then that would be considered repeating because the same digits are repeating over and over in the exact same order. And you know if a decimal is repeating if it has this line on top of the decimals, or 3 little circles like dots, and those mean that the digits keep repeating. Now, as you can see here, all the numbers that are irrational can be written as decimals, but these decimals are non-repeating because they're just in a random order. Now, the rational numbers here, they can be written as fractions or decimals, but they end. Or like 8/9, it's repeating. So as you can conclude, repeating decimals are rational, and then non-repeating decimals are irrational. And then terminating decimals are always rational. So let's practice. So suppose we had 3 again. So when your math teacher asks you that, 3 is rational because you can write that as 3/1. So it is rational. Now suppose we have 0.535, and then that repeats. That would also be rational because it's a decimal that repeats. And then suppose we have the square root of 7. That would be irrational. Because if you write it as a decimal, then it'll just be in a random order, all the digits, so it's non-repeating. And then suppose we have the square root of 4. Now you may be thinking that the square root of 4 is irrational because it's a square root, but it's actually rational because you can simplify that to 2, and you can write 2 as 2 over 1. So that is actually rational. And then if we had 0.07398 and just a bunch of random digits, that would be irrational. Now let's practice some more. So these practice questions, I'm going to let you pause the video and do it on your own. So suppose we have the number 0.444, and then we have the square root of 16, and then we have pi, and we will also include one more. Let's include 9. So I encourage you to pause this video and think about these, and then come back to this video and resume. So now we are back, and for 0.44, let's think about it. 0.44. Well, I know that 0.44 is not repeating because it doesn't have a line on top of it where the digits repeat, or three dots. So that means that it is rational. And then the square root of 16. Well, we can simplify the square root of 16 to 4. So 4 is a whole number, so that is rational. And then pi. Well, pi is a non-repeating decimal, like we said before, so it is irrational. And then we have 9. 9 is a whole number, so it would be rational. If you got these answers, then you are correct. So that is it for today's video. Thank you. Additional practice links will be in the description box below. And feel free to leave a comment below if you have any questions or feedback. And if you like this video and want more videos like this, please like and subscribe. I'd highly appreciate it. And thank you.